The Japanese word Muda, when translated, means uselessness or futility. In lean manufacturing, it refers to the 7 common wastes in production. The 7 wastes are excessive or overproduction waste, excess materials or inventory waste, unnecessary handling of products or materials or transportation waste, unnecessary processes or over-processing waste, time lost waiting for processes or idle time waste, non-essential operator movement or operator motion waste, and defects in the product or bad quality waste. The 7 categories of waste were originally developed as part of the Toyota production system by Taiichi Ohno, the Japanese industrial engineer. They were developed to enable waste to be more easily spotted and identified, so it could then be eliminated. Let's investigate these wastes in a little more detail. Consider a theoretical factory that produces electrical products like smart TVs. Imagine that our factory has orders for 50,000 Type 1 TVs. This is good for the company, so production is set away to produce the 50,000 Type 1s. The manager believes he can easily sell more than the 50,000 Type 1s, and he wants to make sure that there are plenty of extras for the first order just in case there's an issue like a quality problem. So he gets the production team to make 100,000 Type 1 TVs, even though they only have orders for half that quantity. The first 50,000 TVs are produced and shipped to the customer, no problem. Then the extra TVs start to come off the line. There are no new orders yet, so what happens? Well, the TVs are wrapped and placed in the warehouse. More Type 1 TVs are still being made. The warehouse becomes full, still no orders. So the TVs are sent to a temporary storage at an outside warehouse facility at an additional cost. The manager is starting to get worried. He has 50,000 Type 1 TVs to shift with no orders. So he takes action and gets the sales team to offer a discount. The discount helps, and the sales team sell 10,000 of the Type 1 TVs, but at a profit reduction. This has created an additional problem. The regular customer who purchased the original order is now very unhappy as the product has been discounted and they paid the full price. This has created them a sales problem. Our manufacturing company still has 40,000 unsold Type 1 TVs. The warehouse space is still full and the product is getting older and less desirable as technology is moving on and Type 2 and Type 3 TVs are now on the market. Eventually, after time, a decision has to be made to scrap the 40,000 TVs. This is not good as the company has paid for the materials and the labour to make the TVs. The packaging has been purchased and wasted. Charges have been incurred for the storage of the TVs. The TVs have got in the way and filled the warehouse, preventing use for other products and goods. Production time is lost that could have been used to make other new products that had orders, and materials have been wasted that could have also been used on the new products with sales. In addition, time has been lost moving the stock backwards and forwards, and now additional cost has to be incurred to pay for the disposal of the 40,000 Type 1 TVs. The decision to overproduce the 50,000 TVs in the first place has lost time, cost money, interfered with other production, created landfill waste, and has had a negative cash flow effect. In addition, it has had the effect of making the loyal customers unhappy because we have created for them competition problems. The theoretical television manufacturing example has hopefully given you an insight into the waste of overproduction. Overproduction waste is considered the most serious of all the wastes and is sometimes referred to as the mother of wastes or the umbrella waste, as it is often the root cause that can lead to other wastes. Overproduction comes as a natural instinct to people, as there is a tendency when producing parts to produce a few more. This is just to be safe in case there's a problem later further down the line. In addition, bonus schemes or piecework payments incentivize and encourage overproduction to occur. In lean manufacturing, the aim is to work just in time, to produce only what is required, when it's required, with the perfect quality. Overproduction has no place in lean manufacturing. In summary, overproduction wastes includes making too many finished products or subcomponents, making more than the customer requires or making batches of product that are bigger than the customer needs. It also includes making product ahead of the production schedule. Overproduction is a problem for a number of reasons, including: firstly, payment is required for any product produced to cover the costs of labour, materials and resources used. If the product is not sold immediately, it means that the cash is tied up in a product that is not sold and will not be retrieved until the overproduced product is sold. Secondly, extra product produced requires storage, and this will incur costs, as well as the problem that it takes up room that could be used for other more useful purposes. Thirdly, the extra inventory created requires unnecessary movement as it gets in the way of the operations. And finally, if the product is not sold, it will have to be disposed of at an additional cost. Overproduction examples include manufacturing parts in a production process before the next process is ready to use them. This creates the problems of WIP or work in progress on the shop floor, and also the unnecessary cost of lost machine time. Another example could be making too many mobile phones when a new model is coming out. Any high-tech product such as mobile phones runs the risk of obsolescence if a new model comes out, and therefore will create a lot of cost due to having to dispose of the products. Overproduction can occur in any environment. So for example, in a cafe, making more sandwiches than somebody orders is overproduction. If a customer comes in and orders one sandwich and you feel it might be more efficient to make 4, the customer is waiting while the other excess ones are being made, and also there's a risk that the additional 3 sandwiches will not be sold and then will become waste at the end of the day. An example of overproduction waste in an office environment could include printing too many copies of a document. The second of our 7 wastes, or Muda, is inventory waste. Inventory waste is having too much stock laying around, and it can come in any of 3 forms. It's either in raw materials or unused product, work in progress or part assembled goods, or in finished products at the end of the assembly cycle. Inventory waste is a problem because costs have been incurred obtaining the products, parts or ingredients that are then simply left lying around. Inventory also takes up space, and it has to be moved to a storage area or it gets in the way and causes obstructions. In addition, inventory in storage incurs costs and can expire and is at a higher risk of getting damaged. Some examples of inventory waste include producing more product than required in a batch machining process, such as turning metal parts on a lathe, where the batch sizes are made as big as possible to reduce the machine changeover times. On a building site in a construction area, getting all the bricks and tiles onto the building site before the ground is cleared for the foundations. This is waste because the stock cannot be used until the foundations are built. The materials will also get in the way of the construction of the foundations and will continually have to be moved around. Purchasing too much oil for a car and then having to store it somewhere is also another more practical household example of inventory waste. Our third of the 7 wastes is transportation waste. Transportation waste is the unnecessary movement of products or parts around a business. It is caused by having either excessive inventory, a poor factory or process layout, poor workplace organisation, or inappropriate storage areas for materials. Transportation waste is a problem because transporting items takes time, costs money, and is a dangerous activity. Moving stock more frequently or further than necessary increases the risk of handling damage occurring to the parts. It also increases the need for more handling equipment such as forklift trucks and pallet trucks. And with more traffic created in the gangways, there is more risk of hazards and delays being caused to the production system. Transportation waste examples includes making parts and transporting them away for an additional process, something like painting or welding, and then unnecessarily bring them back for inspection when they could have been inspected at the point where they were painted or welded. Putting items into storage and then retrieving them and then putting them back again. This is due to excessive inventory around the shop floor or excessive WIP. This is another example of how transportation waste can occur. Our fourth of the 7 wastes is over-processing waste. This waste is putting more work into the product or service than the customer requires, and it includes having unnecessary processes, having overcomplicated processes, or spending excessive time on setups or downtime. Overprocessing is a problem because process costs are incurred doing tasks that the customer is not willing to pay for and does not need, so resources are wasted. It creates avoidable workflow issues, and it also adversely affects the availability of machinery. Overprocessing examples include using longer threaded bolts than required. This means that time is wasted putting on a nut or screwing the thread up to be tight. Stirring paint if is not needed. Painting the inside of a mobile phone that is never seen and the customer doesn't require. Using too much packaging to wrap parts more than the customer requires, again, is another overprocessing example. And finally, putting more weld onto a joint than is necessary for mechanical purposes, and again, that is not needed by the customer would be another example. Our 5th of the 7 wastes, or Muda, is idle time or waiting time. This is when people are waiting because something unnecessary is preventing them progressing their tasks. It includes waiting for parts to be able to do their job, information to be able to run a machine, materials to do the job. Idle time tends to occur where there is poor balance of work, variation in cycle times, or machinery that requires constant monitoring. Idle time creates problems because people waiting around with nothing to do costs time and money, and no production is taking place. This lost time can only be recovered with overtime. People get bored and frustrated and demotivated when they have to wait around, and it results in poor utilization of equipment and operator time. Examples of idle time include people being unable to do their job because they are waiting for either parts to process, instructions to proceed, machines to be repaired, or computers to work. Our 6th waste involves unnecessary operator motion. Similar to transportation waste, that is the unnecessary movement of parts, operator motion is the unnecessary movement of the operator. So operator motion waste is when unnecessary operator movement or exertion is required to complete a task. It includes excessive walking, stretching, or bending, and it generally results from a badly organized work environment. The operator motion waste is a problem because work tasks take longer than necessary. People get more tired than they should do, and it results in a poor operator environment, increased related work injuries and absence, and a less productive work environment in general. Examples of excessive operator motion include the repetitive walking back and forth to a tool cupboard to obtain tools when the tools could be laid out on a toolboard in the workstation to prevent the walking. Bending down to get things from under a bench when the items could be laid out at bench level to prevent the bending down. Repetitive and a frequent stretching up for parts from racks or shelves when the parts could be rearranged below shoulder level to make it easy to pick up without causing any strains or injuries. Our final waste is the waste of bad quality or defects. As the title suggests, bad quality waste is simply when defects or rejects are produced. Bad quality is a problem because parts will either be scrapped, so wasting resources and incurring disposal costs, reworked, costing extra money and time and causing delays. Bad quality often results in poor capacity and reduced ability to meet production schedules, poor customer satisfaction, high levels of overtime to meet the customer demand, and low confidence in production schedules. Examples of bad quality include producing parts or products incorrectly because they're either the wrong colour, size, shape or form, they don't function correctly, for example, electronics that don't work when they're unwrapped, or they're scratched or damaged, they got surface defects. Finally, it might just be worth a quick mention that the mnemonic Tim Wood is often used to help remember the 7 wastes. T stands for transport, I for inventory, M for motion, W for waiting, O for overproduction, O for overprocessing, and D for defects. That's the 7 wastes in no particular order.